This is the outer central breakwater landfill site. Incombustible waste and ashes from combustible waste are disposed. This is the new sea area waste disposal site. These sites are currently being used for the final disposal of waste generated by the 23 wards of metropolitan Tokyo. The waste we produce in our daily life. Combustible waste. Incombustible waste. Large size waste, such as furniture. And waste that is recycled as a resource, such as newspapers. Waste separated into these categories is collected and carried away by special collection vehicles. This work is undertaken by each of the 23 wards. If the waste were disposed of in its original form, the landfill sites would soon be full. The waste is therefore put through intermediate processing. Combustible waste is incinerated in incineration plants. Incombustible waste is pulverized at incombustible waste processing centers. Large-size waste is pulverized at a pulverizing processing plant. Intermediate processing to reduce the volume of waste buried in landfill sites and so give the sites a longer useful life is the work of the Clean Association of Tokyo 23. The waste, reduced in volume, undergoes final disposal in a landfill site. This is the work of the Tokyo Metropolitan Government Environment Bureau. As a result of the growth in recycling, the volume of waste generated in Tokyo is decreasing. Figures for fiscal year 2000 show that out of 3.5 million tons of waste generated, 870,000 tons was disposed of by burial in landfill sites. If industrial waste is included, the volume buried rises to 1.3 million tons. Now let's look back at the history of the landfill disposal of waste in Tokyo. Starting from the late 1920s, number 8 site at Shiomi was used. Number 14 site at Yume-no-shima. And site number 15 at Wakase. Landfill disposal was also carried out at the inner central breakwater landfill disposal site. Subsequently, it was continued at the outer central breakwater landfill disposal site. And since 1998, landfill disposal has concurrently been carried out at the outer central breakwater landfill disposal site and in Block A of the new sea area waste disposal site. The sea walls for Blocks B and C are now completed, and reclamation work here will be carried out starting with Block B. Following that, Blocks D, E, G and F are to be constructed. Waste will be buried in D and E, G and F will be filled with waste soil. When this site, Yume-no-shima, was filled, it was turned into a public recreation spot with a sports center, a tropical plant center and a park. A smart smokestack rises above the new Koto waste incineration plant, the biggest in Japan. When the Wakasu site had been filled, it became the home of a golf course and a park. Looking into the future, when the new sea area waste disposal site has been filled, 1/3 of it will be reserved for parks and green spaces. In comparison with former times, progress in recycling and intermediate processing has brought about great changes to the waste that is taken for final disposal. Large-size items are pulverized at a crushing facility, and ferrous metal parts are extracted as a reusable resource. Combustible items are taken to processing plants, incinerated, and the ashes buried in landfill sites. Incombustible items are pulverized at a processing center. After ferrous and aluminum parts have been removed, some of the combustible parts are incinerated at the processing plant. The ferrous and aluminum parts that have been removed are recycled. Incinerating combustible items reduces them to ashes and only 1/20th of their original volume before their disposal at a landfill site. At the Orta waste incineration plant, the ashes are liquefied at a temperature of over 1300 degrees Celsius. Cooled, they turn into small vitreous nodules known as slag. As the volume of ashes is reduced by half, dioxin, the toxic substance they contain, is broken down, which helps to protect the environment. At present, fused slag is used as a civil engineering material, but from now on it will be used for a wider range of purposes. Plans have been drawn up to construct additional processing plants like the Orta plant at 7 other locations. It will then be possible to turn all ashes into slag. Slag and waste and ashes reduced in volume are being put in both the outer central breakwater landfill site and the new sea area waste disposal site. We should now like to describe the work that is being done by the Landfill Waste Disposal Administration Office. First comes reception of the waste, ashes and slag which arrive in containers or dump trucks. The weight of the wastes carried in each truck is checked before the truck enters the landfill site. The loads are then taken to the unloading points. The pulverized waste, now without any semblance of its original form, is unloaded from the trucks and spread out flat by bulldozer. It is then tamped down by compactor. This is how the Yume-no-shima site looked in 1962. In those days there was no processing, so the volume of waste was huge and the work was very demanding. Landfill sites filled up rapidly. The volume continued to grow. Processing plants and other facilities were insufficient. The problem became so acute that the then governor of Tokyo declared that conditions amounted to a war against waste. In 1965, there was a huge increase in the population of flies on Yume-no-shima. It brought misery to the people living in nearby areas. Helicopters were used to spread pesticides on the site. Nowadays, in order to preserve a clean environment, the state of insect pest populations is surveyed by means of such things as fly traps, and the least amount of pesticides necessary is spread. At one time, methane given off by buried waste often caught fire. Pipes are now driven into buried waste to draw off methane gas that is built up. In addition, fire trucks patrol the facilities to deal with any fires that gases may cause. To prevent dust or disposed waste from swirling into the air, the ground is sprayed with water. The water used is rainwater or water that has been treated. And to prevent waste from blowing into the sea, wire mesh fences have been erected around the landfill sites. When the waste on a site has built up to a certain thickness, it is covered with a layer of earth. Among the benefits this produces are: wind cannot blow any waste away, the smell of the waste will not spread, insect pests such as flies cannot breed, and as the waste has no contact with the air, there is no danger of fire. In the sandwich method of waste disposal, a layer of soil is spread over the waste, and on this soil more waste is laid, followed by another layer of soil, and so on. The ashes from incinerated waste are deposited in pits excavated in the landfill sites. The waste is then covered with soil. This ensures that ashes will not be spread by wind action. The Landfill Waste Disposal Management Office is the single centre managing the disposal of waste generated by Tokyo's 23 wards. In 2001, it was awarded ISO 14001 accreditation by the International Organization for Standardization. The ISO is an international body established in 1947 in Geneva, Switzerland. Its 14001 standard, introduced in 1996, sets the organizational structure that will allow continuous improvement to environments. The Landfill Management Office has established an environmental policy that aims to create a disposal site appropriate for the 21st century, the century of the environment. The policy covers 7 aspects of its work. One of these, aimed at protecting the environment, is the treatment of polluted water produced by rain seeping into the ground and through the waste. The seawalls of the disposal sites have a solid structure to prevent pollutant. Is therefore collected in pump wells, from where it is sent to a balancing reservoir. The reservoir has a surface area of 5 hectares, is 3 meters deep, and can hold 150,000 tons of water. Even with intense rain or a long period of rain, no polluted water reaches the sea. The marine environment is protected. The water held in the balancing reservoir is sent on to the wastewater treatment facility on the inner central breakwater landfill site. Various methods are employed at the wastewater treatment facility to clean the water it receives. In the activated sludge method, the polluting components are eaten by bacteria. In the chemical coagulation precipitation method, chemicals added to the water coagulate the polluting components. And a method by which polluting components are adsorbed in the same way as is done by household water purifiers. These are ways by which the water is purified. At each stage in the treatment, the quality of the water is analyzed. Some of the treated water is used for sprinkling at the disposal sites. Reuse of the water assists in the conservation of both resources and energy. The remainder of the water is conveyed to the Tsunamachi Water Treatment Center of the Tokyo Metropolitan Sewage Works Bureau, where it is further cleaned before being discharged into the sea. In another step to protect the environment, methane gas that has been generated in the inner central breakwater landfill site is bled off. It is then used for electric power generation.